Okay, now let us do the second part of the projectile motion, lesson 4 of projectile motion. The theory part, and we'll do a numerical at the end also. Projectile projected with a velocity u, making an angle theta with the horizontal. Look, this is your ground, which is horizontal. This is your vertical axis. From the point O, a projectile is projected with a velocity u, making angle theta with the horizontal. Let u is equal to velocity of projection at the point O. Theta, this angle that makes with the horizontal, the velocity vector that makes with the horizontal is theta. Theta is equal to angle made by the velocity vector with the horizontal. Now, from vector analysis, you know how to split this velocity into two components that I have explained you here. Suppose this line represents velocity u. Taking this as the diagonal, consider a parallelogram, which is in fact here a rectangle. So in this triangle, your cos theta will be base over hypotenuse, that is OA over u. Cos theta, OA over u, cross multiply, you get OA is equal to u cos theta. So if this velocity is u, this horizontal component OA is equal to u cos theta. And in the same triangle, take sine theta. Sine of this angle is perpendicular by hypotenuse. This perpendicular is same thing as OB. So sine theta is equal to this side divided by hypotenuse. This side is same thing as OB. So OB over u, because hypotenuse represents the velocity u. Now cross multiplying these two, we get OB is equal to u sine theta. So if you compare this with here, with these dotted lines and this rectangle, if this is your velocity u, this much part is your u cos theta and this much part of you is your u sine theta. So u cos theta, which is represented by this vector, is the horizontal component of the velocity u, and u sine theta, which is represented by the vector OB, is the vertical component of the velocity u. Now this is a velocity. So the component, this component and this component, they are also velocities. Now what these two components do individually? That is the role of this vertical component u sine theta. Due to u sine theta, the projectile moves up. The projectile moves up following this path. Why it is not going up vertically? Because this is also there. This is pulling to this side and this one is pulling it up. So the curve is like this. So due to u sine theta, the projectile moves up against gravity. Its value becomes 0. The value of u sine theta becomes 0 at c. Then it starts increasing in the downward direction. Why is it so? This is the velocity. Earth is pulling to this side, that is acceleration due to gravity is to this side, that is negative. Therefore this will gradually decrease. At the point O, if it is this much, here it will be still less, here it will be still less, here it will be still less, and finally it will be 0 here. Then Earth will pull it down, so this u sine theta will gradually increase, Now the role of u cos theta. Now what is the role of u cos theta? Now u cos theta, a role of u cos theta. Due to u cos theta, the projectile moves along the horizontal direction. Due to this, it is moving to this side. But in this direction, there is no air resistance. So this remains a constant all throughout. Means the value of u cos theta at this point is this much. Here it is also the same u cos theta. Here it is also the same u cos theta. Here also the same, it is again same u cos theta. And just before striking also u cos theta. And here this one will be equal to your u sine theta. Now let us analyze further to do the derivations. Let small t is the time to reach c. Using the relation v is equal to u plus at for vertical for this direction, final velocity is equal to initial velocity plus acceleration into time. the final value of u sine theta at c is 0. So final is 0, and u sine theta is your initial velocity. Initial velocity. Acceleration is negative because g is downward, so minus gt. So gt comes to this side, so gt becomes u sine theta, so t becomes u sine theta over g. That is what I have written here, is equation 1. Let capital T is the time to reach E, this point. Means the level from which it was fired, it was projected, and again it comes back to the same level at E, capital E, in time T. That time to reach E. This time is called time of flight. So this time T will be twice of the small t, 2 times this, because this diagram is symmetrical. If you look at this part and this part, they are symmetrical. So the time to reach C and time to arrive from C to E are equal. So small t, again from here to here is small t. So t plus t is equal to 2t, that is equal to capital T. Now let us find out the maximum height. Let CD is equal to capital H. Let CD is equal to capital H, which is called maximum height. Now using the relation v square minus u square is 2as. Now final square of the final velocity minus square of the initial velocity is 2 times acceleration into the vertical distance traveled. So the final value of u sine theta here is 0. So square of 0 is 0. Initial velocity, the vertical initial velocity is u sine theta. Square of that is equal to minus 2gh. Why minus? Because this acceleration is minus g. This acceleration is minus g because it is downward. So this becomes 0 minus u square sine square theta is equal to minus 2gh. Minus cancels, 2g comes to this side, so h remains on this side. So you have u square sine square theta over 2g is your third equation. Now let us calculate the range. Now let us calculate the range. Now if you look at u cos theta is carrying this projectile towards the right up to the point E, capital E, in time t, and in this direction there is no acceleration or no retardation. Therefore this distance from O to E, I write it as capital R. It is called the range of the projectile. Now so your R will be equal to your speed into time, u cos theta into time t, because capital T is the time to reach E. So u cos theta remains same. For t I replace 2u sin theta by g, which I just derived. So this becomes u into u square to 2 sin theta cos theta over g. Now this is in trigonometry is equal to sine of 2 theta. So r is equal to u square sine 2 theta over g. So equation 4. Now what is the maximum value of this r? Maximum value of r. Now if you look at, this is a fraction for a given u. If u is constant and g is of course constant, therefore this by this is a constant. So the value of r, capital R, depends on sine 2 theta. So if sine 2 theta is maximum, r will be maximum. So r is maximum if sine 2 theta is maximum. Sine 2 theta maximum value in the sine table is 1, that is at sine 90 degree. So sine 2 theta is sine 90, therefore 2 theta is 90, which implies theta is equal to 45. So theta 45, 2 into 45, 90, sine 90 is 1, 1 into u square is u square over g is r maximum. So r maximum is u square over g. Now similarly, maximum value of h. We just derived the value of h was this. For a given u and g, h depends on sine square theta. This is a fraction and this part is in the numerator. So if sine square theta will be maximum, h will be maximum. So the value of sine square theta maximum can be 1. Sine square theta is equal to 1 at which implies taking square root on both sides, sine theta is 1. So sine theta is 1. 1 is same thing as sine 90. So theta is equal to 90 degree. Means if you throw a projectile at 90 degree, then h will be maximum. So put it 1 here, 1 into u square over 2g is 2g. This is your h maximum. Now similarly, similarly the maximum value, let us maximum value for the time of flight. We just derived capital T, the maximum value of T. We know capital T is equal to 2u sine theta over g. That is the time to reach this point E. So if sine theta is maximum, then T will be maximum. So T maximum is equal to 2u over g, because the maximum value of sine theta is equal to 1. That is, in which case sine theta is sine 90, that is theta is equal to 90 degree. So if you throw an projectile making 90 degree with the horizontal, this will be maximum. Now there is a small numerical, rather important. The numerical is like this. For which value of the angle of projection theta, r is equal to h. So we know r is equal to this much from equation 4. We know h is equal to this much from equation 3. It is given they are equal. So let us make them equal. So this is your r and this is your h. Now g cancels, u square cancels. Sine 2 theta is equal to sine square theta. Means sine theta into sine theta over 2. Now sine 2 theta is same thing as 2 sine theta cos theta. That is equal to sine theta into sine theta over 2. So 1 sine theta cancels here. So I am left here with 2 cos theta. I am left here with sine theta. This cos theta goes to this side. This 2 comes to this side. So this becomes 4. On the right side I have tan theta. So tan theta is 4. So theta is equal to tan inverse of 4. If you find out this value in a calculator, it comes out to be nearly 76 degree. That is nearly 59.9 degree. That is nearly 76 degree. So that is all about your projectile motion on a projected at an angle, making angle theta with the horizontal. So I'm going the reverse way actually. I'm going the reverse way so that you will be able to note it down in your notes. Thank you.